I'm going to show you how to graph y equals 2x minus 1 squared plus 2 by using a table of values. I'll show you quickly how to do this, how to shortcut it and do it without a table of values after. So to start off with, I'm going to put in the usual x values that give me a good picture of what's going on. Now, these numbers are not always appropriate, but they are in this particular case. And then one at a time, I'm going to put these values into this function to determine the y value. I'll do that slowly on a separate sheet of paper to clarify how to do it. So I'm going to put in a -3 in place of x. So remember, I have y is equal to 2x minus 1 squared plus 2, and I'm putting in x equals -3. So again, what I'm doing is I'm going to find the y value that goes along with x being -3. So y is equal to 2 times -3 minus 1 squared plus 2. So look closely. All I did was I took x out and I put -3 in its place. Now I'm going to follow the usual order of operations for arithmetic to determine the value. I'll deal with the inside of the brackets first. If I was to start at 0 on a number line, take 3 steps back, then take 1 more step back, that puts me at -4. So -3 minus 1 is -4. So I've got 2 times -4 squared plus 2. -4 squared is -4 times -4. Remember, negative times negative is a positive. Let's do this one aside here. -4 squared is -4 times itself. And negative times negative is a positive. So this is positive 4 times 4, which is 16. So what I have here is y is equal to 2 times 16, because -4 squared is positive 16, plus 2. So y is equal to 2 times 16, which is 32, plus 2. So y is equal to 34. So my first point, when x is -3, y is a positive 34. Let's try the -2. I'll talk less and try and do it a little bit quicker. Remember, I do what's inside the brackets first. That's a -3. -3 squared is positive 9. So my y value now is 20. So I have when x is -3, y is 34. When x is -2, y is 20. I'm going to try x equals -1. So that gives me a 9. Now, I'll let you do the others by yourself. I'll just do them quickly in my head. If we put a 0 in here, if that's a 0, then we've got -1. -1 squared is positive 1. 1 times 2 is 2, plus 2 is 4. So that's going to be a 4. If we put in a positive 1, 1 minus 1 is 0. 0 squared is 0. This whole thing is 0. Well, this one's kind of unique, so I'll take the time to write this one out for you. So I'm now doing the case where x is equal to a positive 1. So y is 2 times 1 minus 1 squared plus 2. Because remember, y is 2x minus 1 squared plus 2. So I put a positive 1 in place of x. That's what I have here. That becomes a 0. 1 minus 1 is 0. So I've got 2 times 0 squared plus 2. 0 squared is 0, so that's 2 times 0 plus 2. And 0 times 2 is 0, so that's 0 plus 2. That gives me a 2. Now, if x is equal to 2, 2 minus 1 is 1. 1 squared is 1. 2 times 1 is 2, plus 2 is 4. So that's going to be a 4. And I can tell ahead of time the next one's going to come out to 9. The reason why I can tell, look at this pattern. Knowing that this is a quadratic's perfectly symmetrical. So if my pattern goes 29, 4, 2, next number is going to be a 9, and the next number is going to be a 20. But don't take my word for it, I'll show you. So we're going to make x equal to 3. So y is equal to 2 times 3 minus 1 squared plus 2. So y is equal to 2 times 2 squared plus 2. 2 squared is 4. And that's not what I expected. Okay, I've got 3. I'm doing y equals 3. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. And then we add 2, we get 10. So that makes this a 10. That's making me question this value right here. Let me try that one again. I think that's the one I did in my head. So what we have here is x equals negative 1. If x is negative 1, y is 2. Negative 1 minus 1 squared plus 2. So y is 2 times negative 1 minus 1 is negative 2. Squared is positive 4. 8 plus 2, that's 10. So I had made a mistake here. This is a 10. So as I was saying earlier, this is going to be perfectly symmetrical. If that's a 10, the next one's going to be a 20. Let's put in a 4 and see. So again, y is equal to 2x minus 1 squared plus 2. And we're dealing with the case when x is equal to 4. So y is equal to 2 times 4 minus 1 squared plus 2. So y is 2 times 3 squared plus 2. 3 squared is 9. So it's 2 times 9 plus 2, making it 18 plus 2, which is 20. So this is a good way to check to see that you're doing things correctly. If you see a pattern, but the pattern is not perfect, then a mistake has been made. There is always a pattern where this is perfectly symmetrical as we go left and right. We call that an even function. So now that that's fixed, to graph this, I'm going to go negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And we want our values to go up, let's say to 20, so I'm going to make that 10 and make that 20. So if we have x equals 0, y is equal to 4, puts me here. When x is 1, y is 2, which will put me there. When x is 2, y is 4, put me back up here. When x is 3, y is 10, so that puts me up here. And when it's negative 1, it's also 10, so that puts me up here. Well, I guess that's right there. Didn't want to write over my number, that's a 10. And when x is 4 or negative 2, we're all the way up to 20. That then gives us this symmetric parabola here. I'm just going to very quickly show you a shortcut way of drawing this just by looking at that. So y is equal to 2x minus 1 squared plus 2. So the way you will learn to do this is you memorize y equals x squared, looks like this. Or you go over 1 up 1, over 2 up 4, over 3 up 9. You just keep going up by the square. And then we apply what we call transformations. This transformation, this minus 1, means we go 1 to the right. This plus 2 means we go 2 up. And then this means this 2 here means we stretch by a factor of 2. So I'm going to apply those 3 transformations to this. I'm going to go 1 to the right. I'm going to go 2 up. So that's 1, that's 2. And I'm going to stretch it. So let me draw it by itself without the original x squared just to make it look a bit cleaner. I go 1 to the right, 2 up, and I stretch it, and very quickly I get a sketch of what it should look like.